Um, Welcome everybody to the second installment of the Compassionate Math Seminar Series. My name is Daniel Filonik, and I will be moderating the session for today. Just to tell you a little bit about myself, my background is in computer science and human-computer interaction, and I've specialized in user interfaces for data analytics and data visualization tasks. So I'm not a mathematician by training, but I would like to thank Priya for introducing me to this amazing group of just creative thinkers and educators and interesting individuals all around who all share this common passion for how to make math more compassionate and more inclusive so that everyone can participate. So that's, I think, enough about us. Maybe just a few words about the format. This seminar, we're trying to run it in a little bit of a different way than your typical academic seminars. We want to highly encourage participation, and we want to speak to people from all different backgrounds. So hopefully the content will be such that no matter what your background is, you can take something away from it and you can participate and engage with us in the discussion. So that being said, we will have a little bit of a presentation by Irfan today and setting up the general topic. If you have any burning questions, you're welcome to interrupt and ask them right away. But otherwise, there will also be time at the end for more in-depth discussion. As I said in the beginning, the session will be recorded and it will be shared later on YouTube on our Relatorium channel. So we will share the link to that in an email, I imagine. And we would like to thank also the Topos Institute for their support of this series. All right, so today we will have Irfan Alam speaking to us. He is a Hans Rademacher Instructor of Mathematics at the University of Pennsylvania, and he has a background in mathematics and philosophy and has recently had a keen interest in the ethical questions around AI and how it relates to mathematics education. So I'm very excited for the session, and I would like to hand over to Irfan, maybe starting with the question. Irfan, can you maybe tell a little bit about yourself and what compassionate mathematics means to you?
Yeah. Thanks, Daniel, and thanks, Priya, and all the people who organized this. So I am a postdoc at Penn, as you said, and I come from India. So I did my bachelor's and master's there, and then came to the US. And when I came to the US, one thing about the US education system that's good is that it lets you study a wide variety of things when you are at a university. So even though I came here for studying mathematics, since the university was paying my tuition, I was able to take philosophy classes. And that's how I got my philosophy degree. So, so after my PhD, I actually got diagnosed with autism, which I'm saying because it's a little bit important to me in the sense that it's a part of my identity, and that is one of the main reasons I started thinking more about how to make education more accessible, because for a lot of neurodivergent people, they are hidden struggles that they face in navigating the education system that are only hidden because we don't often talk about them. So I started working on things like disability advocacy and started veering off a bit from mathematical research. While I still do some mathematical research on my own time, I'm not focused on it solely these days. So now I recently started working with Tomas and Tunga on their really exciting software. They have figured out a way to generate videos, uh, generate videos when you pose a mathematical question to it. And so they're still working on how to make it more and more interactive going forward. But if done well, these types of technologies, they can be real assets in making some part of education more inclusive. There will still be some role of teachers, and I will try to talk about what is the role of teachers in my talk today. But yeah, maybe I should also say a little bit about compassionate mathematics, what it means to me. I think that was also part of the question, right? Okay.
Yes.
Yeah, so I was just thinking about this earlier today, and I thought, what would compassionate English be? Like if this was asked in an English class, or what would be compassionate literature? So I'm saying English or literature because in those fields, at least in the US, uh, at the school level, there are things like dramas that students participate in, and it's like a thing that they look forward to sometimes. I grew up in India. We didn't have that form of compassionate literature there. We didn't have dramas in our schools. We didn't know what it was, and so I guess we lost some of the compassion there when teaching English or literature in India, when we were not exposed to that dramatic form of literature. And so the same way, mathematics has many forms and many ways of thinking, and compassionate mathematics would be inclusive mathematics, not in the sense of inclusion with respect to human characteristics, but inclusion with respect to mathematical characteristics, inclusion of mathematical ideas. There are various ways of thinking about the same mathematical object. And if we do not expose our students to it, then we are not exposing them to mathematics. And so that's my view on compassionate mathematics.
Thank you. Yeah, fantastic answer. All right, with that introduction out of the way, are we going to jump right into the demo, or how did you
Yeah,
plan?
we could do that. Yeah. I think my plan was that we could have a demo for some time, and then I will give my presentation and then the Q&A.
Sounds great to me.
Yeah.
Okay, yeah. Hello, everybody. I'm Thomas.
I'm
This is
Tunga.
Tunga. We can go share our screen now, maybe.
Yep, sure.
So as Professor Irfan said, we've been lucky to be advised by Professor Irfan and Professor Ted for quite a while now, I think over a month. Yeah, quite a while. I think 2 months or something. So what we really do is you can go to the home page, I think.
Yep.
Really, what we are doing right now is that we realize that the way kind of students love, like most prefer interacting with mathematics, and that has proven to be most effective is in some kind of engaging visual format. And there's been a lot of different edtech products, and very few seem to work. And some of you may be familiar with the Bloom's 2 sigma effect. So really, he basically devised that the real impact is done by having some form of private tutoring. So that's our vision in the long term, to be able to, for everybody to have a tool that gives them, like in a personalized manner, some kind of an explanation that they can interact with, as Professor Irfan said. So we're at the very early stage of that. There's a lot of different products and a lot of companies doing it different ways. And so we've been building this for just a few months now, but when you put in a problem in there, you're going to get some kind of a video explanation. Right now, they're pretty dry, and all our time is going into training these models to be more accurate. Now we have pretty high accuracy on like SAT problems. It's like over 95%. And we also make sure that it's taught in a way that students find the most engaging. But long term, we want to have so that the students have a conversation, or that if they like Taylor Swift, they can have Taylor Swift avatar and voice. These are not so difficult things, but it will definitely take time. So I will let Tunga now take over and show the demo. So
Awesome. So this is our interface right now, and what happens is we wanted to make it pretty intuitive, like ChatGPT. You can ask your question, or you can just upload an image. We can just go ahead and upload an image to my computer.
Just some random one, we don't know what it really is.
Okay, I think I did this one before, so let me do another one. Let's open random one. Okay, so this is like an image that you upload and you just send it. And what we do is we first create a solution so that the student can look into and try to understand themselves if they don't want to, if they don't need to watch a video to understand it. But if they feel like there is confusion and they didn't see like how they got from one step to another step, we create the video explanation. And it takes a little time to create it, but I'll show you how other videos we created look like. Let me share my screen again, 1 second. Yeah.
The volume of right circular cone A is 4 cubic meters.
Okay. So this is another video that we generated for a word problem, which is for SAT. And this is what we get. I'm just going to speed it up for the sake of time. 1 second. Can see. Oh, perfect. This is what it
Volume
looks
in
like.
cubic meters of a right circular cone with 2.5 times the radius and 7 times the height of cone A. So let's think about the volume of cone A. Well, we know it's 4 cubic meters. We also know what the formula for this is. It's going to be 1/3 times pi times the radius of the circular base squared times the height, and that's going to be, of course, 4 cubic meters. So that's what they told us. Now, let's think about the volume of this new larger cone. What's it going to be? Well, it's going to be 1/3 times pi. Now, what's the radius going to be for this larger one? Well, it says that it is 2.5 times the radius. So if r is the radius of our original cone, now we're going to have 2.5 r squared. That's the radius of this larger cone, the radius of its base of the larger cone, and then what's its height?
Yeah, and it just continues to
Pi r
solve it
squared
like
each
this.
times. What do we have left over? We have 6.25 times 7.
And then it solves step-by-step solution. And let's look at our video. And yes, our video is generated meanwhile. And let's see.
Let's figure out the value of b for the parallel lines r and t.
Let me speed it up.
Here we have the equation of line r, x plus 2y equals 8. Let's rewrite it in slope-intercept form. Divide by 2 to get y equals -1/2 x plus 4. Substitute the given points, 3, b, and b plus 2, 5, into the slope formula. This is our expression for the slope of line t. Since it's parallel to r, set the slope equal to -1/2. Cross multiply to get rid of the fraction. After distributing, we get -b plus 1 equals 10 minus 2b. We obtain b equals 9. The value of b is 9. Final answer.
I mean, of course, it's not great, but any question you ask, you can create a video like this. For example, we asked another question here that we uploaded, and it generated a
The
video
function f
like
is defined
this.
for all real numbers, and the graph of y equals f
Very
of x
slow
in the
down.
xy plane is a line with a negative slope. Which of the following must be true? Let's analyze the first statement. If a is less than b, then f of a is greater than f of b. Since the function is a line,
So we're
it is
capable
m
of
times-
creating these types of videos.
therefore, statement
We
3
are
is
also doing geometry, but we are in the experimental process for geometry. And when we do it, it's a little more, we have more errors with it and everything. But that's basically what we do. If any of you has a question, we can just ask and see what it generates. If we have time for it. I don't know if it's in the video, but yeah.
I think we could definitely try one audience-generated problem. If someone can come up with one quickly, that would be fun. Otherwise, thank you very much for giving the demo, being brave to give us a live demo. That's very impressive.
Of course.
So let's maybe give people in the audience a few minutes to think about whether they have any problem they would like to see.
You can type in the chat. That would be good.
And if you have any questions also to Tunga directly, you can also unmute yourself and ask.
Yeah, could I ask a question, please, about the just about like the output. Is there a way, so it gives the video output at the moment. Is there a way that educators could use this to get the video output, but then have access to like the source code that generates the video so that they can go and like fix any mistakes they find, or so they can add extra bits or things like this? Or is there a way to like build that functionality in?
Totally. We were also thinking of creating an API for it. So that source code is definitely available. We can just put a button and you can just copy it from there.
Okay, because that would be really cool. I think that's like, as an educator, that's how I could see this being really useful of, you know, making 95% of the video immediately for me, and then I go in and I fix the last 5% and add whatever stuff I
It's a
need.
good
That sounds
idea.
really cool.
That's actually a good idea.
Okay, thanks.
Great, thank you.
Valeria, please go ahead.
Hi, it's very impressive indeed, but I wondered about the source, the data sources that you guys are using. Can you tell me more about it?
Sure. Are you asking about the large language model we're using, or?
Both, which large language model you're using, and kind of what it is. I mean, presumably you're kind of restricting yourself some sort of mathematical subject or something like that.
Yes. So the mathematical capabilities of this right now is for high school math, it's totally able to solve it. And for college math, it can solve calculus, multivariable calculus, but then it struggles with linear algebra. And we're working on making linear algebra 1 possible. And geometry is a whole different area that we are trying to focus on right now. And the data set we are using is, we looked into a lot of math problems, probably like tens of, like 100+ math problems, and we created our own solutions for them, turning them into code so that the AI model can look into example the videos that we generated, just the code of it, and it can replicate that code to some extent. And the LLM model we're using actually just it's very flexible. We can use Gemini, we can use Bard, we can use ChatGPT. Right now, what you see is generated by ChatGPT, but it's mostly dependent on our us fine-tuning it and giving it like quality examples and frameworks that it can generate the videos on.
Thank you. I think I still kind of wanted to know a little bit more about the problems that you kind of guys come up with. Are they kind of in a GitHub repo or something?
No, we keep it private. And the math, are you asking about the math problems?
Yes.
Or the code?
That's right. The math problems, where they're coming from, and if they are part of a bigger set. Because, you know, I think the business of saying that you can solve calculus questions kind of, I mean, from what I have played with ChatGPT, it cannot solve kind of trivial things in depending on what you're kind of asking. So, I mean, I take this claim kind of a little bit with a grain of salt, if you see what I mean.
Yeah.
Yes, for sure. The type of questions that we train our models on are mostly from if it's high school, it's SAT practice exams and SAT practice resources online that are available, like the questions Khan Academy solves. But we are more accurate than ChatGPT because we specialize the model to work on these type of math questions. And in the last time we didn't do the test, an external student did the test, and we were 26% more accurate, but still this is like an area of improvement. So accuracy is something to take with a grain of salt.
Right. Thank you.
That's fantastic. I think maybe at this point we can move on and give Irfan time, or is there still one urgent question?
Well, Daniel, I just was wondering if they are, first of all, thank you guys for demonstrating a live, practice kind of problem solving. But I wonder if you are prepared, or if you were asking for an actual problem that's not on your prepared list that you could upload.
Yeah, sure.
To demonstrate for us the ability to upload it. Like, what would it take to upload a new problem? I mean, I have a problem, for example, to give you, and I wonder if you could demonstrate for us, is there time to do this, or should we leave it for later?
Yeah, I think we can do it because we can be flexible, and I can stop in between my talk also for questions like this.
My suggestion would have been, since we didn't get an immediate response to the prompt, maybe we can move on to Irfan's presentation, and then we can try the problem in the discussion at the end of the seminar. If someone comes up with a problem by then, I think that might be a good way to go about it. But
yeah, that's also, yeah.
Thanks again for the amazing demo. So now that we've seen what these systems are capable of. Maybe Irfan, you can provide us a little bit more context and your perspective on what all of this means for you as an educator and for all of us.
Okay, let me share my screen. All right, so give me 1 second. Okay. So what I will talk about today is basically going through some of the ideas in these 4 articles, and then often talking about the context of these articles when thinking about what is happening right now with technology and what types of technologies we now have for improving math education. So I will try to basically discuss whether we need to reevaluate what we are teaching and how we are teaching now that technology can do a lot of the simple things that we used to struggle to teach before. Not that it's going to do it better than a human, but it's going to help a lot. So we can reevaluate and think about whether we have been teaching the types of mathematics we want to teach, and if not, then how should future math classes look like? And so these 4 articles will mostly be used as context for the types of arguments I will make for future of math classes. So the first one, I will highlight some of the things here so you can treat a lot of this talk as like book reading. I will read this book to you. So he's saying mathematicians disagree on the axioms of set theory, what they are and how much they matter. But they agree on the theorems of the calculus, and they come together in department meetings to discuss calculus, how it should be taught, which text to use. And such discussions might have as much to offer philosophy as the occasional symposium on the foundations of mathematics. And moreover, our teaching practices, not our philosophy journals, might offer the more accurate seismograph for recording shifts in the foundations of mathematics. So he's giving the example that this article is from the 80s. So in the 80s, computer science was emerging, just like right now, AI technologies are emerging. And as computer science was emerging, there was a reorganization of the types of mathematics we wanted to teach. We started having a renewed focus on combinatorics and finite mathematics, which was not focused as much in those days before this reorganization due to computer science. And now combinatorics is one of the most active areas of mathematics these days in terms of numbers of papers published per year. So the shifts in teaching practices, which actually often are determined by what is happening outside in the world, are tied to major reorganizations of the field. And so I want to argue, first of all, that this meeting that we are having right now to discuss how to implement new and emerging technologies in our classrooms, this meeting would have as much to offer philosophy as the occasional symposium on the foundations of mathematics, in using the words of the author. Because the way our teaching will evolve with these technologies will determine the future of mathematics, and that will determine to some extent, not determine, that will be important for philosophy of mathematics. And major shifts in teaching practices could be tied to major reorganizations of the field as a whole. And I would want to argue that a major shift or some major shifts in teaching practices will happen sooner or later because of the new technologies compelling us to do that. All right, so right, so here the author is saying about talking about mathematicians, that if teaching is where they get their money, research is where they get their status. So this is talking about a societal phenomenon where we separate teaching and research. We think that if someone is a teacher, then they cannot be a researcher, and that also leads to lots of issues in academia. But I will digress. The author is basically trying to establish the important role a teacher plays in telling the student that mathematics is something that can spark creativity. It makes perfect sense to speak of teaching mathematical creativity. And sometimes it is done very explicitly, as in Moore style courses. And for those who don't know what that is, I will have a blurb up in the next slide. But finally, in raising these pedagogical questions, the questions of how to teach and what to teach, mathematicians are confronting the ultimate question: what is the purpose of mathematics? They are exercising their critical function. And what is the critical function? That's of determining the continuation of the mathematical community, because how we teach and what we teach will determine what types of mathematics will exist in the future. So that's the type of stage I would like to set up when we want to think about what is the future of mathematics education. Any burning questions at this point? I guess more style courses I can. Yeah. So this was actually at UPenn where I work right now. So I didn't know this until a week or two ago, that Moore was someone at UPenn who taught this course, this type of course where the context the content of the course was presented in whole or in part by the students themselves. So there was no textbook. Students were just given definitions and ideas, ideas about what types of things are true. And then students were expected to use the definitions to discover ways of reaching those conclusions that we know. So I think I will talk a bit more about this later, about how we should add context to our math classes. But this is an example of that, where you give the context, you give definitions, maybe the motivations behind the definitions, maybe some of the things that are known and the context behind those things that are known, and then let the students discover on their own. Right. So yeah.
Irfan, I have a question. I wonder if what you mean by what is the purpose of mathematics, can be accessed first by thinking about what is it that the students are actually learning, or how do you see it relating to that question? In other words, and in Moore's example, I mean, I think he's attempting to address that. But there's the thing that we as teachers are trying to teach them, but how do we figure out what it is that the students are actually learning? And do we give them the space to express that, let alone figuring out if that was how it aligns with the purpose?
Yeah, I feel like the purpose of mathematics itself is it's like a multi-dimensional thing. Like there are various aspects of thinking about the purpose. One would be what is the purpose of mathematics education? So what types of ideas and values we want to instill in our students through our mathematics education? And then the question would be whether such ideas and values are being instilled by the mathematics education that we provide. I think, but maybe I'm deviating from the question you're asking me. Am I deviating? Could you remind your question?
I just wondered what you think, and if it fits now, or you can address it later. But my question is, to what extent we're asking what the students themselves are learning rather than what we intend to teach them.
Yeah, there should be something that we should intend to teach them. Yes, I would say. Let's discuss this in the discussion later, because I think I'm getting distracted by it. Sorry. So yeah, so the third takeaway I would do from that article is that it makes perfect sense to speak of teaching mathematical creativity. So when we talk about teaching mathematics, there should be a discussion about whether we are teaching creativity or not, because if you're not, then you're not teaching some of mathematics. And something from the article, a quote was that even errors can take on a positive connotation in a sympathetic learning environment, because you can learn from your errors and then that develops intuition. And then some of the most important philosophical questions that mathematicians ask themselves are what to teach and how to teach it. So that's a quote from earlier. But as we were just discussing, in raising these questions, we are actually talking about how we envision the future of the mathematical community, because these are the students who will take up the burden of continuing the human endeavor of mathematics in the future generations. And the author himself in his article concludes with this sentence. He says, in making room for the concept of mathematicians in the philosophy of mathematics, perhaps we are making room for mathematicians themselves. So this is an article from the 80s. Philosophy of mathematics itself has undergone lots of changes since then, and by now philosophy of mathematical practice is a very common term, and so it is of course well accepted these days that mathematicians should be an important part of the conversation when we are talking about the philosophy of mathematics. But I still wanted to start with this slightly older article, because at its time, it asked the right type of questions. At its time, also, mathematics was changing in some sense, because, as he was saying, computer science was reorganizing some of the teaching focus of mathematics at that time. So that's the first exhibit. And then the next one, I will talk a bit about this article from the recent bulletin of the AMS by Michael Harris. Automation compels mathematicians to reflect on our values. So as the previous article also mentioned, we need to think about what our values are that we want to be teaching. And right now is the time to reflect on those values partly. Michael Harris is talking more than just teaching values, but let's look into it. So Harris talks a lot about what it would mean for mathematics to live deliberately in the face of existential challenge. So I will not go into what he technically means by these things. I don't think he also has precise definitions of these. So we are reading this in kind of in a literary sense.
That's a quote from Thoreau.
Yeah, sorry?
That's a quote from Thoreau.
Oh.
I went to the woods to live deliberately.
Yeah, there was a quote. Maybe this was the quote. That might be my mistake in copying and not remembering to say it was a quote. So the article itself had a quote. What would it mean for mathematics to live deliberately? Maybe think mathematicians to live deliberately. So living deliberately should at least mean that we should know what we are vibrating about, which is referring to this, I guess, song talking about how we are just all sitting here and vibrating, and we don't know what we are vibrating about. So so we need to understand as a mathematical community what we are about, what we are doing when we are teaching, what's the point of teaching, what values we want to inculcate in our students. But Harris's article is a little bit of a critical article, and it's an important critical article. I think everyone should read this article. he criticizes the mathematical community to not that he criticizes them that they do not acknowledge this vast literature on automation, many of which are written from the standpoint of history, economics, political science, sociology, and even the humanities. In a sense, mathematicians, when they write about automation, they focus on they do not think about mathematician jobs being replaced or things of that nature. Their focus is more on theorem provers and proof checkers and things of that nature. But if we Yeah, I think I'm getting a little bit ahead of myself. He's going to talk about how those other departments, those humanities departments, are actually struggling these days, and mathematicians would benefit from talking to them a bit about as well, because there might be, depending on how technology is implemented, if the policymakers believe that teachers are not important, then it can lead to lots of unemployment. That might be a big social issue. But to really counter that, we have to come up with ways to integrate the technology in our learning environment so that we have a pretty good understanding of what we want to teach and how we are going to get aid from technology to reach the level we want to reach. We can reach higher levels now because of technology, but we need to actually think about those values. And Akshay Venkatesh's essay actually spurred a lot of these articles in the recent AMS bulletins. It was an essentially explicit call for mathematicians to examine the implications of AI for what we value most in the practice of our profession, and to take action to defend our acknowledged values. And one benefit of doing that is that at least it provides us an opportunity to agree on what these values are, because we rarely get these opportunities. Okay, so I will probably not go through a lot of these just in the interest of time, but I encourage everyone to read his article. It's very important. He criticizes that there is no serious attempt on the part of mathematicians to come to grips with the deep instability of the model of higher education that provides our livelihood. So I think the questions that Harris raises can be coupled with the observation of how these learning aids are developing, and then we can ask questions to universities about what is their plan for running classes in the future. That's a question, that's a conversation that needs to happen, for example. That's one of the social implications of these types of technologies, because we need to plan for such future classes. And yeah, I will go through this quickly. If automation does provoke a crisis in mathematics, which I think is likely, given the imbalance of forces, it will be in the first place a crisis of meaning. So maybe someone might ask, what's the point of teachers if AI tutors can teach? So we should explain to them what is the point of teachers, and we should first come up with an idea of what our collective values are regarding what is the point of a teacher. Okay. So my takeaways are that we should think about these questions. What are the most urgent questions about the future of mathematics education? I'm actually quoting Harris a little bit. I put education at the end. He said, what are the most urgent questions about the future of mathematics? Is higher, he said higher education, I'm saying education in general. Is education an industry, or is it a public good? I think he was referencing some other article from somewhere. Will we have a crisis of meaning in mathematics education, and how, and maybe if it is a possibility, then how do we work towards going away from it? Okay, so that's the second exhibit. Now, the third one is a more positive article by Eugenia Cheng. And she's talking about how technology is already changing the way we do mathematics. And so we should celebrate that this allows more people into mathematics. And so she's not afraid of human mathematics becoming redundant in the face of technological advances. And the reason is because we want to use technologies as aids to figure out how to make mathematics even more inclusive. And so being inclusive means there should be someone doing mathematics, right? So we should not worry that human mathematics will die if we bring more students into the creative aspects of doing mathematics. So she has coined these terms ingressive and congressive behaviors. She wants to talk about congressive mathematics, where we would not talk about who is first or who is fastest or who is getting the right answers and who is the most brilliant, but we should be worrying about whether we are exploring the ideas or not, whether we are in the pursuit of discovery or not, whether we are attempting to make that connections or not, and whether we are bringing more people into the discussion or not. So Eugenia Cheng and I also believe that the world education and particularly math education has been rewarding ingressive behavior for far too long at the expense of congressive behavior, which is arguably more beneficial to society and to mathematics. Now, again, about technology, she's talking about how there were a lot of skills we needed in the past, but now we don't because of technology. So she is welcoming technology. But she is also pointing out that we should recognize that now the ability to assess what counts as good information and what does not is one of the important skills that people need to develop because of our life being so pervaded by technology and technology having all sorts of information. For teaching and learning, Eugenia Cheng says that she always tries to give students something more than they would get from reading a book. But then eventually, this is what she thought when she was younger. As she got older, YouTube videos became a thing, and now she could create YouTube videos explaining math. And so she needed to change her baseline for lecturing. It was no longer enough to be more than a book. It needed to be more than a video. And we are at that stage even more literally. Now it's not just the existing videos that are there. Pretty soon, sooner or later at least, we will have technologies that will generate videos. So if a teacher is teaching, they need to be more than a video. So we need to also be deciding what does it mean to be more than a video. Okay, and some lecturers fear that they may lose their jobs, but Cheng says that there will always be things that I can do that technology can't, and we need to figure out what those things are so that we can promote those. And she laments that most teaching jobs come with no incentive to make changes to courses, and indeed disincentives to do so. And at least, I guess, one good thing about these AI technologies is that it has given us the incentive to think about these things. And finally, maybe math education needs a change that was long overdue, at least in this country. And at least now we have an incentive to think about it. So, yeah.
Irfan, just so you know, it would be great if we can wrap up in around 5 minutes to leave a bit room for the discussion.
Yeah, I will go through the next one blazingly fast, and then I will finish it.
Perfect.
Yeah. So yeah, I will probably just ask you to read this article. Everyone should read this article who is interested in thinking about the future of math education. Lockhart was a mathematician who later became a high school teacher, and I think is still a high school teacher, if not retired. And he wrote this when he was a high school teacher, and I think later wrote a book with the same title as well. So this is a 25-page essay, but it's talking about how we have not been communicating the idea that mathematics is an art. So we have been obscuring the creative aspects of doing mathematics, and how how the way we treat math education would not be accepted in any other type of art education. He's asking you to imagine a scenario in which music education became the way he is describing, and how that would be like a nightmare scenario. And sadly, he says our present system of mathematics education is precisely this type of nightmare. So I have a lot of this, but I will just not go through it. I think this is more suitable for a longer talk. I will show the 3 takeaways I took from Lockhart's article. He says the difference between math and the other arts, such as music and painting, is that our culture does not recognize it as such. So I would say now that we are reorganizing our teaching methods, we should focus on this also. Why not fix this issue? Why not promote the idea that mathematics can be recognized as an art? So if you deny students the opportunity to engage with this activity, to pose their own problems, make their own conjectures and discoveries, to be wrong, to be creatively frustrated, to have an inspiration, and to cobble together their own explanations and proofs, you deny them mathematics itself. So that's also about compassionate mathematics. We need to be aware that or compassionate about the idea that students have different ways of understanding, and we need the students to discover their own ways of understanding, because that's when they can build their personal relationship with mathematics. And why aren't we giving our students a chance to even hear about these things, let alone giving them an opportunity to actually do some mathematics and so on? So yeah, it's just comparing how no other subject is routinely taught without any mention of its context. So I would say that when we have these AI technologies, I would say mathematics education should focus more on context going forward in general. I would say we are at an inflection point, and we can go up or down. I won't say we are going down, but to go up in the kind of directions we kind of want to go up as a mathematical community, we need to evaluate our values and decide to do what types of courses we want. So we have the potential to improve our collective societal understanding of mathematics if we change mathematics education in the right ways. Or I should not say there is one right or one wrong way, but if we collectively think about this actively, we have this potential. But we need to be conscious of this goal and actively work on it, and not delay it. I think it's almost urgent because the commercial nature of these technologies. And experimental courses with a view toward vision of mathematics education for the future are actually critical right now. That's my message. And I would, if I was given a chance to create a course, I would probably create something like calculus for general audiences. I would have students from all sorts of backgrounds, and I would focus lectures on all sorts of context behind the basic ideas, and then AI tutors could give personalized attention to students for problem solving, and depending on their levels, the tutors would be very helpful in bringing them up to the sort of minimal level we want, uh, and we would still need some human interactions, because that has its own set of advantages that AI cannot replace. So I think that's the end of my talk, actually.
All right, fantastic. Thank you very much, Irfan, for this amazing history of math education and contemporary thoughts on it. I think everyone will appreciate if we can share the articles that you've mentioned also after the talk in an email. It's been quite interesting to hear. So I think with that, we can move to the discussion. If there are any questions from the audience to Irfan, please feel free to raise them now. And otherwise, we did get a few suggestions of some problems in the chat as well while we were discussing or listening. So we can maybe showcase one or two of those. But yeah, please go ahead. And if you have any questions, ask them now.
I will maybe repeat then, Irfan, the question I had mentioned earlier and see if it sparks a conversation right now. I wonder, what the students are learning as opposed to the difference between what we intend to teach them versus whether we look to find out what the students are actually learning and giving space for them to express that.
Whether we look to find are you saying the difference between what we want to teach them and what they are actually learning, or is that a different question?
I mean, possibly the difference between the two, but they're wired to learn. Brains are wired to learn, just like AI will learn something. But the question is, can we figure out is this part of the pedagogy? It seemed like some of the things you were sharing with us were pointing in this direction to give, especially the Lockhart piece very explicitly, to give more voice to the learner. And so I wonder if that's part of the practice and if it can be facilitated with an AI interaction somehow.
With AI interaction, I think I think we have been telling like giving advice to Tomas and Tunga about how to make this more interactive. I'm not sure how far the technology is right now, but I think there should be ways to have a conversation with the system and make it like a human dialogue between the students and the AI. And so it won't, I think it won't just be the AI, the system giving a solution via video form, but it could be a video having a dialogue with you in some form. If maybe Tunga and Tomas can say better about what's possible in that sphere.
Sorry, what was the exact question you were referring to?
Yeah, I was wondering to what extent the AI environment can facilitate our asking the question of what the students are learning rather than what we intend to teach them. Another way to say this now, inspired by what Irfan just said, how you rephrased it, is that there's a view of mathematical and perhaps more general sense making that is fundamentally dialogic, that it comes about through a dialogue. And so it isn't a question of just telling me the right answer, or, in other words, like, I'm testing you, can you tell me the right answer? But more like, you're going to reply with another question maybe, and we are exchanging something, which eventually leads us to develop the sense of understanding, some that we feel we got it. So I wonder if an AI environment that's capable of so much already from what you've shown us, if it can be leveraged in a way that can enhance that aspect of teaching, which, sometimes isn't focused on enough.
You mean through like the discussion with the student and challenging?
Yeah.
Yeah, we actually discussed this aspect to integrate it into the program, where the program will facilitate a conversation with the student. So it's definitely something that's possible. And I mean, the good question is whether students will really like this, because we find that a lot of students nowadays really rely on some passive way of learning. So I think we kind of want to find the sweet spot for that, because YouTube and this, like 90+% of students we asked and we tested it on say that they use YouTube on a regular basis, which really inspired us to do this. ChatGPT is very complex, and math textbooks, frankly, are not read a lot by students because it's just so complex, so energy draining. So what you're referring to, Ted, is quite a good solution to that, where it will provide a discussion, and maybe the student can turn the mode on or off if he wants or she wants a more passive versus more active discussion. It's definitely possible to do that. I mean, do you have anything to add to that, Tunga?
Yeah, I think I'm on the same page with you.
I mean, the reason I'm saying this, aside from philosophical considerations, is that the practice of teaching, you know, in my practice of teaching, I very often am deliberately ambiguous about things I tell the students, or even occasionally make mistakes and leverage them because I'm expecting interaction. I want, well, I mean, so you can see this philosophically in the context of what Irfan is saying as, you know, I'm trying to promote the value of blah, 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 whatever. But the point I'm making now is more instrumental. Like, this helps me get a sense of what the student's sense making is. Whereas the AI, at least superficially from an input-output perspective, from what we saw, is mainly focused on whether it gets the right answer or not. Like, I'm testing it, like it's trying to pass a test.
If I may jump in, when you want to customize these things and you have an interaction with the student, you have to have a mental model of the student. And what he's talking about is that he knows that there are open pieces in the mental model which are gaps. By purposely presenting the gaps, he's trying to figure out whether they are able to think through it. This is a very important component of teaching. And if you go back to tutoring systems in the early days of AI, you will see people talking about this notion of cognitive model of the student and the instructor, that is the system. It has a model of what is correct, what is wrong, and based on that, it customizes the kind of instruction it gives. So that's, you have to move towards that if you want to achieve what you're talking about.
Yes, that's a good point. And it definitely helps the program to collect data based on the student's gaps to be able to create a profile on the student and tailor it to its needs. That's what you're referring to, right?
Yeah, in which case you have to have a conceptual model of the student and the gaps between the different concepts and what is the correct set of concepts and relationship and which ones they mistake usually. You see? So you have to use these two things as a way to think about this problem.
It's also, yes, absolutely. And thank you for the clarification. And indeed, that was a problem early on that's been described in automatic tutoring environments. I would say the problem is even harder than that, in that often there isn't a unique mapping between you know, the correct answer and the correct way to get to the answer.
Right.
And I mean, that very much speaks to the compassionate mathematics. And so for example, the problem that, I don't know if you guys got a chance to see the response to the example that I showed, that I shared earlier.
Yeah, we shared the answer to it, actually.
I did.
I think it would be nice to actually show that for the audience that might also be watching this later on, the recording.
Maybe you should share that. Can you?
So we can have a look maybe at one of the answers. You can pick the one that you feel like is most representative of your system's capabilities.
Yeah, we can show Ted's actually question.
This is the wrong answer, but we can still show the animations. Yeah. 1 second. Sure, which one is
so I just want to suggest to you guys, it's an old book. It's called Intelligent Tutoring Systems, and you should take a look at it. It is a very well-written book on the issues of intelligent tutoring.
Great, thank you. Intelligent
Tutoring System. I think it is, if I'm not wrong, it is by Etienne Wenger.
So this is an answer to the question from, I think, 1 second. I think it's from Ted.
Yeah.
Well, this is,
Given the system of equations and inequality.
and it is not super accurate. I think it made a mistake somewhere. I didn't check the correct answer, but this is what we generated.
We're asked to solve for the variables. First, express x_3 from the second equation. This allows us to represent x_3 in terms of x_2. Solving for x_3 gives us x_3 equals 3x_2 minus 5. Next, substitute x_3 into the inequality x_3 left 0. This substitution results in the inequality 3x underscore 2 minus 5 less than or equal to 0. Adding 5 to both sides, we get 3x underscore 2 less than or equal to 5. Add 5 to both sides to isolate the term with x underscore 2. Finally, divide both sides by 3 to isolate x underscore 2, giving us x underscore 2 less than or equal to 5/3.
Yeah.
Now substitute x underscore 3 into the third inequality, x underscore 3 plus x underscore 4, GEQ 3. Substitute the value of x underscore 3. Simplify the equation to 3x
I think
underscore.
for now on it's gonna do a wrong solution because it made a mistake before here.
So can I interject at this point for just a moment? When I
Yes.
went through it on my own on the side, I was doing it. I realized that one thing that's conspicuously missing here, aside from that little mistake there, is any kind of motivation. You see, you're manipulating standard forms, right? You're moving, different, you're trying to get to some form that you think will give you the answer. But there's no motivation. It's simply a statement of fact. I do this, I do that, I do that, or you do that, which I think what the student wants is exactly the complement of that, the motivation. I would just sort of ask them in a situation like this, what do you think the next thing should be? Where would you like to be at? And then you figure out what you need to do to get there. Telling you what you need to do to get there is not just taking away the learning, it's sort of like not even asking the right question almost. Do you see what I mean? Like why? Because there's non-uniqueness. You could do other things and still get to the same answer, but like what makes you choose to do this rather than something else?
Yeah.
That's the problem.
No, you're totally right.
I was checking something.
And really, the next thing, we have to master this stage where we are able to have accurate solutions and we're able to have accurate videos and accurate animations for them, even though it's dry, even though it's not engaging, even though it doesn't interact with the students as you suggest, and challenges the students to really get the full understanding. I hope that we will have the chance to tune in again in maybe 3 months or so, where once we master this, and this will be the next thing. I'm sure of that. It's very difficult to pass this first stage accurately, but that's really what we see, the dream of the AI tutor. That's what we're building. So you're completely right, and we completely agree.
I have one final comment. Again, first of all, I'm very pleased with what I saw. This is very impressive, not knowing how to do this myself. I can only imagine how difficult it is. But the final thing that I would add is that maybe you can think about how to inquire the system or the student, encourage the students, what protocol they have to verify that the answer is correct. So not just state the answer, and maybe you think you can follow the steps and you think you're convinced, but how do you know at the end? Is there an independent validation? Is there some way that even if you didn't understand all the steps, you're convinced that it's correct? Because especially, I mean, this is always a problem in a classroom when they hear this teacher and they assume the teacher knows. But I think it's even more a problem when it's an AI, because there's this notion of an oracle. It just knows the right answer. I'm just going to gloss over the details, and whatever it tells me must be right. And obviously we saw that's not the case. So can we encourage them to seek some sort of protocol of verification? I think, as Irfan mentioned, this is an area of research in automated proof verification and so on in mathematics and category theory. So perhaps some of that you can leverage.
Thank you. Yeah, I think with that, we're reaching the end of our time, but that was a fantastic session. And I think it was very fitting that in the end, the AI made a mistake, because as we heard from Irfan, so in the right environment, even an error can be a positive. So hopefully we had the right environment. And I think it shows, a lot of potential. I think you're very brave to take questions from the audience like this and put your demo to the test. So yeah, I would like to thank everyone again for this fascinating session. And we will follow up with an email and keep the discussion going. And I certainly would like to see in a few months' time where this ends up.
Yeah, thank you very much for having us. Feel free to check out our website, MotionShark.com, and email us if you have any follow-up We have our email on the website. Any follow-up questions or suggestions, we're always happy to talk with experienced researchers and mathematicians and computer
Teachers.
scientists, teachers. You know, that's always helpful. Or if you want to test it, or if you have students that would be interested, feel free to let us know. Thank you very much for having us.
Bravo.
Thank you.